Good morning. This is the first day of the last part of trig, the third part of trig. So this is the warm-up. It says, given an oblique triangle, which is a triangle that is not a right triangle. A non-right triangle, we can still solve for the missing sides and angles. So we know that if this is the altitude or the height of the triangle, sine of A is opposite, or h, over hypotenuse, which is little b. Little c, little a. Sine of B would be in this triangle. If B was my reference angle, my opposite side would be h over the hypotenuse would be a. So it says solve each expression for h. Well, if I cross multiplied, I put like sine over 1, and I cross multiplied, I would get h equals b times sine of a. And if I cross multiplied this one, if I put a 1 underneath it and I cross multiplied, h equals a times sine of b. Since h is equal, I know that a times sine of b equals b times sine of a. And what we did was we divided everything by both sides by a times b. Both sides. If we do that to the left, we can multiply the right hand side by 1 over a times b also. And what we're left with is the a's will cancel. So sine of b over b equals sine of a over a. And this became a ratio. This ratio is the law of sines. So sine of the angle A over side A equals sine of the angle B over side B. And that's also equal to sine of angle C over side C. When they give us information such as the angle, the next angle, and then the next side, that this works. Or if they give us angle, side, angle, this works. But if they give us angle, and then a side, or the reverse of this would be a side, this is the same thing, a side, and then an angle. Remember we said there's no bad words in geometry? Well, there's no bad words in pre-calc either. So this is the one way it doesn't work. We call this the ambiguous case. The ambiguous case. This one may not work. So it says solve the oblique triangle with B, C, and little b 210. Okay, so we're gonna have to draw a triangle. It's very important that you guys draw a triangle. It's not a right triangle. Maybe it looks something like this. We know that we can label it any way we want. I'm gonna say capital A is here, capital B is here, capital C is here. Remember that your angles are the capital letters, your vertices, the corners are the capital letters. The ones across are gonna be your lowercase letters. These are your side lengths. And then plug in your information. They tell you that B is 20 degrees. C is 31 degrees. And side B is 210 degrees. So I know that I can put that here, 210, not 210 degrees. So side B is 210. So this means that we're given an angle, and then a side. An angle, and a side. This one works. We can do this. In order to find the third angle in a triangle, we add these two up. 20 plus 31 plus angle A has to equal 180. So we just add them up, subtract it from 180. So this is going to be 51, subtract that from 180. Angle A is equal to 129 degrees. Okay? And we're going to use the law of sines to find the missing sides. We have to use the side that we have the same angle and the side length. We have to use this ratio. So this ratio is sine of b over lowercase b equals, and we can find any other ones. We can do c first if you want. Sine of c over lowercase c, and then we'll do also sine of a over lowercase a. We know this one. Sine of b is 20, so sine of 20 degrees over b itself is 210. We have to use this one. Sine of c, we know c. Sine of c, I'm just going to write it down. Sine c is 31 over lowercase c. Lowercase c, we don't know. So I'm going to make that my variable, actually. I'm going to, remember there's only one variable. Whenever there's a fraction on both sides of my equal signs, I'm just going to cross multiply. You're going to need a calculator for this. So 210 times sine of 31 is 210 sine of 31 equals c times sine of 20. Remember, we cannot multiply c times 20. That's not a thing. It's sine of 20. So the c has to come out in front. I can divide by sine of 20 to get rid of, to find c. Divide by sine of 20. So c equals 210 sine of 31 divided by sine of 20. Use your alpha y equals so that you don't make a mistake on this. That gives us c is, I think, about 316.2. All right, now let's find a, little a. So I still have to use the same ratio. This is the only ratio that they gave me. So I'm going to use the sine of 20 over 210, but this time I'm going to use a. So sine of a, oh, well, a is 129. We found that one. Over little a, I don't know. And then we're just going to cross multiply again. We have a sine of 20 equals 210 sine of 129. Divide by sine of 20. A equals 210 sine of 129. Oops. Over sine of 20. So a, angle A we found is 129. C we found is 316.2. I don't have a unit, so whatever units that is. And then A, I think if you plug this in your calculator, you get something like approximately 477.2, something like that. Check it out. All right, the course for a boat race starts at point A and proceeds in the direction south, 52 degrees west. So it looks like this is 52 degrees west to point B. Then the direction south, 40 degrees east to point C. So this right here would be 40 degrees east. And finally, back to point A. Point C lies 8 kilometers directly south of point A. So we know that C to A is 8 kilometers, so I know my units this time. Approximate the total distance of the race course. Well, I know if these lines are parallel, and we're going straight down and straight up. So these are parallel, and this is my transversal. These are alternating, ah, sorry. These are alternating interior angles. So, I'm sorry, I had 52 right here, and I had 8 kilometers here, and they told me that this is 40, so I know also that this angle is going to be 40. Now I have to find angle B by adding these two up and subtracting them from 180. 52 plus 40 is 92. And when I subtract this, I get angle B, which I think is 88 degrees. Alrighty. Now, I have this side. I need at least one side. I have this side. I'm actually given an angle, a side, and an angle. So this one would be angle, side angle. This is not ambiguous. This is perfect. Point C lies 8 kilometers south. Approximate the total distance of the race course. So I need to find, I'm going to have to find C. And I'm going to have to find A. So this is C and this is A. Alrighty, I have to use this ratio. We're given this angle and the opposite side. I have to use this ratio. So sine of 88 over the side length 8 equals, and we can find A or C first. Let's do A. Sine of 52 over the side length is A. When we cross multiply, we get A sine 88 equals 8 sine 52. Divide by sine of 88. A equals 8 sine 52 over sine 88 is maybe about 6.31 kilometers. I want you guys to find C. So we're going to set them up the same way, still sine of 88 over 8 equals sine C is 40 over C. And I want you to tell me what C is, and then we have to add them all up. So the total distance of the race course is 6.31 plus the 8 kilometers plus whatever we get for C. And then tell me what we get. This says that we can recall from geometry that side-side angle or angle side-side was not a way to prove that triangles were congruent. It says, as a result, there may be either no triangle, one triangle, or two triangles that can satisfy these conditions. We might be able to draw a line and make two out of them. To solve sine of theta equals 1/2, this happens when theta is equal to 30 degrees. But there's other places where sine is positive 1/2. I know at 30 degrees, and this reference angle is also going to be 30 degrees. So 180 minus 30 is 150 degrees also. So in quadrant 2, it could be 150 degrees. So this equation, they give us, or this example, they give us a side, and an angle. Remember, this one is our ambiguous case. Let's check it out. I'm going to draw it open until we know how many triangles we are. We're not going to close it. I'm going to make A right here. It doesn't matter. Put it anywhere you want. B is going to be right here, and then C is right here. It says A is 35 degrees. Lowercase a, side A is 6. B is 8 centimeters, and that's it. So I know that I can use my ratio. I know sine of 35 over 6 can equal, well, we don't know angle B or angle C, so I can't find them. So let's do sine of angle B over B, which is 8. And let's solve this. What I'm going to do is I'm going to cross multiply. So I have 6 times sine of B equals 8 times sine of 35. Divide by 6. Sine of B equals 8 times sine of 35 over 6. If we plug this into the calculator, the sine inverse, we're going to get B equals 49.9 degrees, approximately 49.9 degrees. Now, if I do need this. If I want to find C now, I can. I know that 49.9 plus 35, and then plus angle C equals 180. I can add these up, subtract it from 180, and I'm going to get that angle C is, I think, 95.1. Check it out. Okay, now I can find side C. I can find this little c over here. I know that sine of 35 over 6 equals sine of 95.1 over C. We're going to cross multiply. C sine 35 equals 6 sine 95.1. Divide by sine of 35. C equals 6 sine of 95.1 over sine of 35. So C is going to equal 10.4 centimeters. This all works out if there is one triangle. This works. There's 10.4 centimeters. So the ambiguous case means that this triangle could be split up into two triangles. So instead of B being 49.9, B could be, this side could be 49.9, and then we're always going to subtract it from 180. 180 minus 49.9 will give us 154.6. And that means that this could be, maybe we can make this one like D or something like this. And we can find C on this side, and we can find, we'll have to find C and D on this side. Okay, so this could be two different triangles. I'm sorry, so I fixed it. This is going to be B2, and this will be the angle of B2. So to check to see if there could be two triangles, what we're going to have to do is we're going to have to check to see this big triangle can add up to be less than 180, because we still have angle C. So this big triangle is 35 plus the 130.1. Is that less than 180? Well, that equals, I think, 165.1, which is less than 180. So that means angle C can be something. And this means that there could be two triangles. I know this ambiguous case is a little confusing. We're going to do an investigation on it. I want you guys to try the other ones. If you have any questions, we'll go over it in class. Have a great day.